Good evening, everyone. We will be discussing the Leetcode problem number 448. So, what we will be asked in this is that find all the numbers that is disappeared in an array. We are given an array like this, and it is told that it is having elements which are ranging from 1 to n. So I have told you that if there is a question in which it says that an array contains an element in the range from 1 to n or 0 to n, then we can think for the cyclic sort. So here we will be finding the elements which are not coming here. For example, let's see here. We have elements from 1 to 8, and here you can see that some of the elements are missing like 5, 6. Okay, so what we will be doing is that, so first of all we will sort our given array with the help of the cyclic sort, and in this you all know that what we will do first is that in the cyclic sort what we do is that if the element, we find the correct index of our element. This is the first step, that is the correct index. And when we have the element ranging from 1 to n, the correct index will be what? For example, let's say I have element 1 2 3 4. Okay, and the correct index will be what? 0 1 2 3. The 1 will be present at the 0th index, 2 will be present at the first index, 3 will be present at the second index. So the correct index will be nums of I, whatever will be the value of our element minus 1. Okay, so now we will check two conditions. If the element is already present at its correct index, then we will just skip and we will move to the next element, that is if the correct index and our I value are equal, we will do what? We will do just I plus plus, move to the next element. And the second is that we can see some of the duplications of the element, and we will check that if the element present at that ith value and the element present at the correct index, these two things are equal, then also we will just do is update our I value and move to the next element. So see what will happen through this example, like 4 3 2 7 8 2 3 and then 1. So our I will be initialized from 0. So for I is equal to 0, our element value is 4. The correct index for the 4 will be 4 minus 1, that will be 3. So it will be checking whether the correct index value and the I value are same. No, the correct index value is 3 and the I value is 0. So there will be no updation. Now the second check, that is the nums of I, that is our 4, and the nums at the correct index, that is 3. 0 1 2 3, 7 is present here. So are they equal? No, they are not equal. So what will happen? It will just swapping will take place and 4 will be going to its correct position and we'll be getting 7 3 2 4 8 2 3 1. Now what? Now again the I value is not updated, it is still here. It will be checking for 7. For 7 our correct index will be coming out to be 6. So again it will check two conditions, is I is equal to 0 and the correct index 6 are equal? No, they are not, so no updation of I. Second is that the element present at the correct index, that is 6. Let's see, 0 1 2 3 4 5 6, 3 is present here, and nums of I, that is 7. Are they both equal? No, they are not equal, so no updation of I. Swapping will take place and 7 will be going to its correct position and we will be getting 3 3 2 4 8 2 7 1. Now again I will be still pointing here. Again the same concept will be applied, and it is found that the 3 is not present at its correct index. So where it will go? It will go to the second index, that is 0 1 and 2. So swapping will be taking place between these two elements and we will check 2 3 3 4 8 2 7 and 1. Okay, again our i's value is still pointing here only. So through the same concept, I will be going to its correct index, that is 2 minus 1, that is 1. 0 and 1. swapping will be taking place between 2 and 3. So 3, 2, 3, 4, 8, 2, 7 and 1. Again it will be checking for I is equal to 0, that is 3. 3 is what the correct index is, 3 minus 1 2. Now you see that 2 3 is already present correct index and 3 is also present here, that is it is a duplicate element. So we will just do nothing here and move to I plus plus, that is I will be 1. Now I will be pointing here. It will check that for 2 the correct index is 1 and the I value is also 1. So then again it will update and it will go to its next value, that is I is equal to 2. The same concept will be applied for I is equal to 3 and it will move to the next element, that is I is equal to 3. Next element is 4 and it is also presented as correct element. Now again it will I value will be updated, I is equal to 4. Now let's see, for I is equal to 4 8 is seen. For 8 the correct index will be what, 7. So here no updation of I because the correct index value and the I are not equal. And let's see what about the element present at the 7th index, 0 1 2 3 4 5 6 7. Okay, so we found out that these two elements are also not equal. So what will happen, swapping will take place. So we will be now getting 3 2 3 4 1 2 7 and 8. Now where our element is pointing, that is I is equal to 4. Again it will be checking for 1. For 1 the correct index will be 0. So swapping will take place between 3 and 1. So 1 will be going to its correct position. So let's see it. That will be 1 2 3 4 3 2 7 and 8. So where my I is pointing, it is pointing towards this value, that is I is equal to 4. Now again it will be checking for 3. For 3 the correct index is 2 and we can see that at the second index already 3 is present. So these two are same. So it will update its I value. Updating its I value, it will get I is equal to 5. Again the same concept, the 2 should be present at 1 but already a duplicate element is present there. So nothing will happen and I will again be updated. I is equal to 6. So at I is equal to 6 7 is present and the correct position of the 7 is already 6. So if our correct index and the I value both are equal, then nothing happens. Then again updation of the I value, that is I is equal to 7. Same thing for here, nothing will happen, I will be updated. Even now this time I will be updated, it will be coming out of the array. So we are getting a sorted array with the duplicate elements at some of the indexes. So till here we have completed our sorting part and we are getting 1 2 3 4 3 2 7 and 8. Now just see, let me write the indexes 0 1 2 3 4 5 6 7. So you can see that if the element is present at its correct index, its value is what, its value is j plus 1. I am seeing this, that the 1 is present at its correct index and what is its value, 0 plus 1. It is present at its correct index, what is its value, 1 plus 1, that is 2. So now we will be running a for loop over each element and we will check if our element present at the j index is not equal to j plus 1, then we will just return our j plus 1, that will be our missing element. Just see here, we see that 3, but what should be here, here should be 5, and we check that for the condition that 3 is not equal to 5. Okay, so we will what do, we will just return our j plus 1. So we will not return, we will append it to a vector because in this question we have to return a vector. So we will just append this value towards a vector. So by doing this we will be getting a vector of the elements which are not included in this array. Okay, so now move to our code part. In code is what we are going to do, and let's suppose n is the size of our array. We will initialize an int I is equal to 0. Okay, and then we will be initializing while I is less than n. Then what, then we will be finding our correct index, that is int take it inside the loop, that is int correct index. it will be equal to what? The value of the element minus 1. Okay, so now our two conditions, that is the first one is that if the correct index is equal to I, or the element present at the I is equal to the element present at the correct index. If these two things are happening, we will do nothing but I plus plus. Okay, else otherwise we will what do? That is the swap between the nums of I and the nums of correct index. Okay, so till here we have completed our swapping part. Now let's see the loop. Now for loop, what we will do, we will apply a loop, that is for int j is equal to 0, j should be less than n, and j plus plus, and we will be checking that if the element present at the jth index is not equal to j plus 1, then what we will do, we will be appending it to a vector, that is whose name is answer push underscore back. We use the push underscore back method to append a value, that will be j plus 1, and at last what we will do, we will return our answer vector. You can initialize the answer vector just before this loop only, and for initializing we will do vector int and then answer. So with this you can see the complete code reference which you can follow to build your own code and solve this easy level problem on the Leetcode, which is on the one of the important concept, that is the cyclic sort.